How many times have we heard about plans to colonize Mars? I sometimes get the impression we're watching space agencies play the Settlers of Mars board game. Dr. Frederick Marin from the Strasbourg Astronomical Observatory has determined how many people are required to establish a full-fledged colony on the red planet. According to him, 98 people will be needed to set up a healthy population. Just to compare, only 12 astronauts have ever stepped on the moon in the entirety of human history. In Mars, given its rarefied atmosphere, extreme temperatures, and exposure to high doses of cosmic radiation, is way more dangerous than our lovely satellite. In this video, I'll answer the following questions. How will a huge magnetic shield between Mars and the Sun save us? Why do settlers build ice houses? And most importantly, will the Martian colonies survive? The first problem the settlers will face is how to actually bring humans to Mars. A flight from Earth to the red planet will take around 7 months. The first migrants will have to cover a distance 150 times greater than that between our planet and the Moon. The ship will need a great deal of fuel to complete the trip. And the heavier the tanks are, the heavier the whole spacecraft is, and the more fuel it requires. That's a vicious circle, and it jeopardizes a lot of NASA's planned crewed missions to Mars. However, scientists have found a solution. Walter Engeland from NASA's Langley Research Center offers the following. It's known that a significant part of the fuel is wasted during landing. If we leave the main spacecraft with all the supplies in Mars orbit and send the crew to the surface in a small lander, we can reduce fuel consumption. Here lies another problem, though. How to make the lander safely reach the ground. The atmosphere of Mars is quite rarefied, and the average surface pressure is just 610 pascals, which is almost 100 times less than here on Earth. And the landing will be anything but soft. A space vehicle touches down smoothly only if it enters the atmosphere at an angle of 12 degrees. Within 2 minutes, the ship's speed will drop from 20,000 kilometers per hour to 1,600, and then the heat shield will come into play. It'll protect the spacecraft from the heat of 1,000 degrees Celsius that its body can reach in this process. At around 10 kilometers above the red planet's surface, the ship will open its parachute to slow its descent. Then at 2 kilometers up, it'll fire its retro rockets. It usually takes about 6 minutes to land a vehicle on Mars. At NASA, they call them the 7 minutes of terror. Long story short, it won't be easy to take the first settlers to the red planet. But what awaits them after arriving at the destination? Oddly enough, the colonization of Mars begins on the Moon. Professor Lucy Berthoud from the University of Bristol thinks that the mission to Mars would likely require us to build a base beyond Earth's orbit. NASA's planning to launch the Lunar Gateway space station into the Moon's orbit in the present decade. It'll serve as a staging point for astronauts on their way to Mars. Futurists from Future Timeline believe that in the late 20s, we'll be able to send 2 nuclear-powered cargo spacecraft to Mars. And by the early 30s, the first SpaceX Starships will travel to the red planet with around 30 people on board. However, Professor Lucy Berthoud thinks that before that moment, scientists will have to master the technology needed to extract oxygen, water, and methane from Mars's atmosphere. Otherwise, the colonization will be impossible, as you simply can't take enough reserve oxygen with you, as well as enough water and fuel necessary for a crew of 30 people. It's unrealistic. But perhaps we can take the essentials to provide for fewer people's needs, at least for a while. But then there's another problem. How do we set up a base? Scientists tend to count on 3D printing. They plan to use Martian regolith as a raw material, since there's a whole bunch of it on the planet's surface. Among alternative materials, they mention even ice. NASA's Langley Research Center, together with Search and Clouds AO, developed the concept of the ice house. It's made of an inflatable dome and decompression chamber. The dome is filled with locally harvested water that later freezes, as the average temperature on Mars is minus 60 degrees Celsius. As a result, we get a proper main structure. Ice walls can protect astronauts from cosmic and solar radiation. The building can even be used as a storage tank and even as a habitat module. But at the same time, the ice house is not suited for growing plants. For this purpose, Interstellar Lab has designed a modular system of inflatable domes. They work as self-contained greenhouses where we can grow vegetables, flowers, and insects. The company won NASA's Deep Space Food Challenge and is going to build one of these greenhouses in low Earth orbit already this year. When the greenhouses and first habitat modules are created on Mars, we'll be able to send there a new group of settlers, astronauts, scientists, miners, and workers. The next stage of colonization is one of the most challenging ones. While miners on Earth extract such things as coal, ore, or gold, the primary natural resource on Mars will be ice. Since there's no fresh water on the planet, settlers will have to acquire it on their own. They'll also have to start large-scale mining of regolith that will be further used to 3D print new habitat modules. But it's still not enough if we want the base to function independently of Earth's resources. NASA experts assume that Mars may contain rich deposits of copper, iron, tungsten, uranium, and gold. And we'll need special robots and new settlers to extract them. This is where another problem lies. Scientists believe that the reserves of mineral resources on Mars can let the colony survive only a few hundred years. What's the point of building a base that costs billions of dollars if it'll only last a couple of centuries? Don't jump to conclusions just yet, though. I should mention that Mars is situated close to the asteroid belt, and asteroids are a nearly endless source of valuable minerals. The NASA Institute for Advanced Concepts is currently studying the most promising asteroids in terms of sustainable resources, and such companies as Transastra Corporation and Keys are already planning asteroid mining missions. The Mars base will only make the task easier, although if the red planet needs to host workers and miners apart from everyone else, there will eventually be a lack of space. What do you think will be the biggest challenge humans will face on Mars? Low temperatures of up to minus 125 degrees Celsius, gravity that's almost 3 times weaker than here on Earth, or unbreathable air are all minor troubles compared to cosmic rays. The thing is, Mars doesn't have a global magnetic field to protect it, so the average radiation level on its surface is approximately 24 rads per year. On Earth, this figure is nearly 40 times lower, just 0.6 rads per year. That's the greatest danger waiting for the settlers. They'll have to hide in underground modules or build a base under a giant dome. And no one's going to care about terraforming when it feels like a nuclear reactor has just exploded outside your window. So, how can we protect astronauts from cosmic radiation? James Green, NASA's chief scientist, has proposed to launch a magnetic dipole shield to a stable orbit between Mars and the Sun. This shield will generate an artificial magnetic field with a strength of 1 or 2 Teslas and will be able to protect the surface of Mars and its dwellers from solar winds and radiation. Scientists think it'll help increase the planet's temperature a bit as well, and even thicken its atmosphere. If we manage to deploy this magnetic shield, settlers will be able to begin the next phase of terraforming, growing plants right in the Martian soil. As you already know, the planet's surface is fine regolith, but this material won't do in this case. Scholars at the University of Florida and NASA specialists have done experiments with cyanobacteria that can survive even in arid environments of Earth. They discovered that these bacteria can detoxify and enrich Martian soil, and so make it plant-friendly. Now I guess we'll need another crew of settlers with farming experience. Let's see what we've got. 100 potential settlers out of the 98 needed. Congratulations. It seems that we know how to play this game, and that we'll finally colonize Mars against all odds. Though life on the red planet will be somewhat different from what we might expect. Instead of admiring beautiful sunsets from Martian domes, the settlers will be working in greenhouses, working in mines, working 24/7. Or rather, 24.57. So, are you still in?